Hi, my name is Karin Eriksson and I'm presenting the project The Political Dimensions of Electricity, Distribution in a Future Electrified and Climate-Neutral Energy System. This project focuses primarily on the development of the transmission and distribution grids and on how the development and possibility to adapt to increased electrification and more variable electricity production is influenced by the institutional context, such as regulations and norms. It is a 4-year project and we're still in the starting phase. The research team consists of our newly recruited PhD student, Hanne Sonnsjö, and of Bengt Johansson and me. We all work at the Division Environmental and Energy System Studies at Lund University. We also have an advisory board linked to the project. The advisory board gathers various stakeholders who we hope to engage with and gain new insights from. The overarching aim of this project is to advance the understanding of institutional aspects and barriers for sustainable, robust and competitive electricity system in Sweden. More specifically, we aim to, on a more general level, analyze the role of institutions in the evolution of large socio-technical systems. We aim to identify pros and cons with different market regulations and market designs, for example, energy only versus capacity mechanisms. We also aim to identify goal conflicts and synergies in energy policy and legislation, and to study the role and responsibilities of different actors in the electricity system in a regional and national perspective. We also aim to study the potential of alternatives to grid investments, for example, flexibility in demand, energy storage, and local energy communities. Some of the methods and activities that we see ahead include literature and policy analysis of the historical development and rationale behind market design and regulations in a European context. We also wish to engage in stakeholder dialogues and to do interviews with the Swedish energy users, the actors in the energy sectors, regulators and policy actors. And in order to learn more about different regulatory strategies, we plan to do comparative studies of different European countries, possibly Denmark, Norway, Germany, the UK. Okay, thank you for listening.
Hi, my name is Abzul Siddiqui and I'm a professor at Stockholm University. I'm part of the STRING project in collaboration with the Chalmers University of Technology. In this work, we will explore the interactions among storage, transmission, and renewable production in the Nordic power sector. The starting point for our work is the fact that the Nordic countries want to lead by example in the sustainable energy transition. For example, Sweden wants to have a 100% renewable power sector by the year 2045. This will mean in practice that most of the energy produced in the power sector will be coming from variable renewable energy sources, such as wind and solar power. Now they have the advantage that they don't produce any carbon emissions, but their disadvantage is that their output is intermittent. This means that they'll need flexibility on the supply side in order to balance the power system between supply and demand. Now the Nordic countries are lucky in the sense that they have large hydro reservoirs, especially in Norway and Sweden, that could be used as large batteries to store the excess production from wind and solar during periods of low demand, and then to release the water from the reservoirs to produce energy during periods of high demand when possibly variable renewable energy production is low. This is, however, an optimistic reading of the situation that assumes that all of the power companies are perfectly competitive. In reality, the Nordic power sector, like many others around the world, is deregulated, which means that most of the generation capacity is owned by profit-maximizing power companies, some of which have enough market share to be able to move energy or water around in order to shift the prices to their advantage. This kind of distortion is known as market power, and this can cause the social objective of maximizing welfare to come into conflict with the private objective of maximizing profit. So what we will do in this work is to develop game theoretic models that are sufficiently detailed with physical realism from the engineering side and representation of the market behavior from the economic side to allow us to address the following set of questions. First of all, even under a perfectly competitive assumption, what is going to be the impact on the prices and welfare from ever-increasing amounts of variable renewable energy production? Next, we will allow for this strategic behavior by market participants that enables market power to result in order to understand what's the additional impact of such distortions on prices and welfare. Next, we will understand what are the countervailing mechanisms that could be introduced in order to mitigate such distortions by adding an upper level to the problem in which a regulated entity such as the Environmental Protection Agency or the transmission system operator can make decisions regarding the carbon targets or the addition of transmission lines in order to reduce the distortions by anticipating the strategic behavior at the lower level.
Good morning everyone, my name is Massimo Bongiorno from Chalmers, and in today's speech I'm going to briefly describe one of the projects that have been recently granted here at Chalmers, which is entitled Beyond the Concept of Virtual Synchronous Machine Control. This project will be conducted by a PhD student here at Chalmers, and it is done in cooperation with Svenska Kraftnät, which is also a financer for the project, and with ZEHTC ABB Power Grids Research. The basic idea behind this project is that, as we all know, the power system is going through a transition where we aim at accommodating more and more renewable energy sources. And for this reason, we are also facing a shift on the way how converters are controlled. As we all know, converters are today controlled in a way that they have to follow the grid. So basically they measure current and voltage, and then the controller has to decide how to inject the desired amount of active and reactive power. As it is also stated in the new requirements from ENTSO-E, converters are going to be asked instead to act as grid-forming converters, so basically to have similar properties as classical synchronous generators. In this respect, we can say that we are going from the concept of inertia to the concept of synchrony for the power system. This is because synchronous generators have a certain amount of inertia that they pose to the system due to physical laws. Physically, there is a mass rotating a synchronous generator. This does not exist in a converter. In addition to that, we can say that there is no natural behavior from the converters, but they are very much dependent on the control strategies that is selected by the manufacturers. Finally, what we have also to consider is that a converter is a fully controllable device, but the converter does simply what we tell them to do. There is no natural behavior or a physical law behind the converter's action towards the grid. So for this reason, what we want to do is to look on what is after the concept of synchronous machine control. That is because a converter can do much more than simply mimicking a traditional device like a synchronous machine. So the main goals for this project is to develop control algorithms for converters that allow to provide the same grid forming properties of a classical synchronous machine, but also take advantages of the fast speed of response that is typical from a converter system. Also, we want to evaluate the performance on the investigated controllers for different properties of the connecting grid, for example, for a different amount of synchronous machines that are connected, or different characteristics of the connecting load. Also, we want to look at the impact of coordination that we can have between different converters selected that are connected to the power system. and to investigate the need for information and communication between converters and the advantage of remote sensing that we can have in the power system. Finally, of course, as it is typically the case for these type of projects, we want to have detailed simulations and to perform experimental validation through prototypes that are built here in our Power System Lab. Thank you very much, and bye.
Hej och välkomna till Ludvika. Mitt namn är Christian Ahlholm och jag jobbar på I2G, vilket är ett litet konsultbolag som levererar tjänster inom högspänningsteknik och elkraftsystemstudier. Vi vet alla att det pågår en stor förändring i elnätet idag. Omställningen till förnyelsebar elproduktion bidrar till större osäkerhet i kraftnätets framtida utformning och dess tillförlitlighet. Inom branschen finns idag också en önskan om att övergå från tidsbaserat till konditionsbaserat underhåll. Man vill också på flera ställen maximera utnyttjandegraden av nätet med hjälp av dynamisk belastbarhet. Lösningen på många problem vid denna omställningen innefattar sensorer och kommer därför leda till en mer utbredd användning av sensorer för övervakning av olika anläggningsdelar i nätet. För övervakning av kraftledningar, som nästan alltid breder ut sig över stora områden, där det saknas möjligheter till nätanslutning, är detta ett problem. Här måste man förlita sig på batteridrift eller mycket energisnåla sensorer. Ett annat alternativ är att installera utrustning direkt på fasledarna, vilket innebär driftavbrott vid installation och underhåll. I2Gs lösning på detta problem är att utveckla en kraftförsörjningsenhet till sensorer och övervakningssystem för kraftledningar. Den underhållsfria kraftförsörjningen utnyttjar inducerade strömmar som cirkulerar i ledningens topplinor för att tillhandahålla energi till utrustning på jordpotential. Utrustningen kan således installeras utan driftavbrott och ge förhållandevis stor effekt. Enkelt kan man säga att vi kommer erbjuda ett 12-voltsuttag vid varje kraftledningsstolpe i transmissionsnätet. Våra primära kunder är således sensortillverkare och stamnätsoperatörer. Genom detta projekt kommer vi skapa en prototyp samt ta fram designmetodik för att snabbt och enkelt kunna anpassa produkten efter kunders önskemål om efterfrågad och tillgänglig effekt och energi. Vi kommer under projektet att verifiera prototypens funktion i labbmiljö och därefter ska en pilotinstallation göras hos någon av våra potentiella kunder. Tack så mycket.
Bakgrunden till vårt projekt med Väla är att marknaden har öppnat upp sig och det speglar också behovet av att lösa framtidens utmaningar. Det är nu möjligt att använda förbrukningsflexibilitet på FCR-marknaden och även lokala marknader för kapacitetsbrist har öppnat upp. I Finland är det här med flexibilitet något som vi har jobbat med länge och vi har idag cirka 300 uppkopplade fastigheter. Det är inte längre i pilotstadiet utan sker på kommersiell basis. Kommersiella byggnader är intressanta för det finns redan ett BMS-system, alltså ett byggnadsautomationssystem i fastigheten. De har ofta en högre grad av digitalisering och det finns befintliga energiresurser på plats såsom värmepumpar, kylmaskiner och ventilationsaggregat. Det är även relativt tröga system. Varför projektet har kretsat kring Väla är för att vi har ett långt samarbete kring energieffektivisering, men det är också en progressiv kund som jobbar med elbilsladdning och solcellsanläggningar redan. Men det är också en perfekt fastighet att jobba med då den har en högre grad av digitalisering. Under sommaren så har vi varit i en projektutvecklingsfas där vi har tagit fram en teknisk lösning och också testat av våra energiresurser på plats. Bland annat utifrån ett komfortbehov men även sett om energiresurserna har klarat av de tekniska krav som finns på marknaden. Vi har en pågående dialog med Svenska kraftnät och vi har haft en mängd möten kring sakfrågor och också förutsättningarna att på ett kostnadseffektivt sätt kunna realisera den här typen av projekt. Vi har även skickat en budkabel till Svenska kraftnät under Kraft 2020 där vi just påtalade de förändringar som behövs. Vi har även en pågående dialog med Energimarknadsinspektionen
och de har varit nyfikna på de erfarenheter som vi har skaffat oss hittills i projektet. Vi har bland annat fått ge inspel på frågor som handlar om mätning, men även på kommande regelverk om oberoende aggregatorer. Och vi har insett att vi som teknikleverantör kan bidra med mycket i myndigheternas arbete med just den här typen av frågor. Just nu så befinner vi oss i ett stadie där vi ska gå in i en implementeringsfas. Vi ska prekvalificera anläggningen, vi ska påbörja arbetet med drift, men även med budgivning och uppföljning. Och vi ser också att den här lösningen är intressant och det är något som vi ämnar att skala. Det är ett stort intresse och många aktörer har hört av sig till oss och ser möjligheterna. Och vi har flera pågående projekt och diskussioner igång just nu.
Hello, my name is Lars Nordström and I'm here to give a short pitch about the project called InfoFlex, or in Swedish, informationsutbyte för effektiv och säker marknadsbaserad aktivering av distribuerade flexibla resurser. The scope of the project is really to enable interoperability for demand response applications. Those conducting the project are me and my group at KTH with the Division of Electric Power and Energy Systems, and also Professor Valerie Vyatkin's group at LTU, Luleå University of Technology. And we're really grateful for the sponsorship of the Energimyndigheten. So the idea of the project is really to go to the core of the problem when we want to deploy massive flexible resources, or rather deploy demand response solutions utilizing massive flexible resources. Flexible resources and end user flexibility has been judged as a key component to make sure that we can integrate large amounts of renewable and non-dispatchable production in the power system. Well, these sources come from many different industries or parts of society, including residential heating, industrial systems, commercial HVAC systems, charging of electric vehicles, etc. And all of those could be or are parts of standalone stub-piped communications infrastructures. For instance, for electric vehicles, there is protocols being developed for how to communicate with the electric vehicle. Similarly, for communicating with demand response resources at the residential area, there is protocols such as OpenADR being developed. What we want to do in this project is to enable a semantic modeling approach that allows us to look at the resource as such, a certain amount of power being available at a certain amount of time, not whether it comes from an electric vehicle, from a heating system, or from an HVAC system. What we want to do is to enable a platform to communicate with these resources without having to care about the exact communication protocol. So what we've been working with is to set up a test platform with a small microgrid and a set of small controllers that all communicate with various protocols with the resources. But then we're trying to set up a unified broker based on a semantic model that can communicate with all of them. So that once we know the amount of power we need from the grid in flexible terms, the communication can be made seamlessly from the market or the aggregator that wishes to activate a certain flexibility resource. Project is kind of software based, but we're really hoping for some interesting results. Want to know more? Contact me, Lars Nordström at KTH. Hello, my name is Lars Nordström, and this is a short pitch for a project called Smarta Skydd, or Smart Protection. This is actually a follow-up project to one that we had earlier on, so that's why this has the name Steg 2 or Step 2. The focus of the project is on developing new protection functions for power systems with a lot of distributed generation in it. And it's run by me at KTH, but most of the work is done by PhD students. Two of them have been involved. There is Tindra Butsin and also Fabian Horn, who are the real workers in this project. Next slide shows some of the content and aim of the project. In a power system with much more distributed generation, the protection system needs to cope with situations where there are faults that perhaps separates the system and leaves parts of the power system still energized by distributed energy sources such as wind power plants or PV in the local distribution grid. So what we've done, one thing in this project is to develop a statistics or learning-based approach to do early detection of such incidents, even in the case when there is a balance between load and generation in the island, which would prevent conventional protection systems from detecting such islanding events. So that's a novelty, and we have some publications on that, which we're really happy about. We've been also looking at the actual protection system, the technical platform that is needed to make these new types of functions available. And for this reason, we've been looking at ways to integrate much higher sampling rates in the protection functions in order to enable time-based or traveling wave-based protection functions in the protection systems of today. This is required since there is a need for a much faster response time to faults, given that the inertia is much lower in the developing power system than those of the past or of today, if we like. The graph here to the right shows first the system we've created for the learning approach here, where we're wanting to detect islanding in a power system as soon as possible. And this bottom half shows the technical platform, where we're looking critically at the time steps, the time delays involved in making sure that high sampling rate signals can be utilized in the protection system. So that's a short pitch for the Smarter Skydd or Smart Protection project. Thanks from me.
Hey, I'm Marcus Jöcker, and I'm a project manager at Siemens Energy in Finspång, Sweden. As a project leader for the Zero Emissions Hydrogen Turbine Center, I will now show you the setup, the aim, and some results of that project. Facing the urgency to change our energy system, we are very glad for this project and the support we receive from the Swedish Energy Agency and the European framework ERA-NET Smart Energy Systems. The heart of that project is really to build and operate a demonstration plant, which includes a gas turbine to be run on locally produced hydrogen. The project is also strongly linked to local and regional interests. This is promoted and communicated by our governmental partners in Finspång and also in Östergötland. The link to the academic partners is likewise important. They give us the insights to optimization and scaling effects of such energy systems. Here, Chalmers University and Bologna University contribute complementary to us. From industry, Linde Gas AB supports us as an observer and in all gas-related topics. Now, turning to the next slide, you see a list of key questions for that project. They highlight the aims in terms of technology, market, and stakeholder involvement. On the technology side, it's important that the project demonstrates how gas turbines could optimally be integrated in renewable energy systems. So here we have an electrolyzer in the project, which produces hydrogen. We have a storage systems and also a solar power plant. On the right side, you see an illustration. They show the main components and how they are connected to the site in Finspång. On the market aspect, the project explores the future role of gas turbines in the energy system. Gas turbines provide stability and flexibility to the electricity grid. And with the capability to burn green fuels, they pave the way for decarbonized solutions. Another important part of the project is the adoption and stakeholder integration. Here we want to share all specific knowledge, and we see highly relevance for power and gas solutions and cross-sector coupling solutions. After nearly 1 year of project execution, we had many dialogues and some learnings. They are focused on the design and installation, safety and risk handling of such a plant. We explore also the decarbonization of the Finspång site, which is very exciting. Thank you very much for your attention.
Hello everyone, my name is Anna Nilsson and I work at IVL, Swedish Environmental Research Institute, as a project manager, and I'm also coordinator of the Flexi-Sync project, which is an AeroNet Smart Energy Systems project. And this project is really about district energy, district heating and cooling. And there are 16 partners in this project. IVL is in charge of the coordination and the communication. We also have responsibility for one of the work packages, as do Chalmers and Luleå and Rice and Utilifeed. So there are a couple of research institutes and academic partners, and then we have Utilifeed and NODA, which are energy service providers, and they are in charge of the platforms that are being developed and the software and hardware solutions. And then we have a couple of demonstration sites. We have one in Borås, one in Eskilstuna, and one in Mölndal. So we have also a couple of district heating companies and housing companies as partners in this project. And since this also is an international project, we have 4 partners in Austria, Germany, and Spain as well. And this project started in August 2019, and it will run until October 2022. And the main objective of this project is to identify how flexibility in district energy can be optimized and thereby contribute to the management of the existing mismatch between weather-dependent electricity production and a variable demand. So this is really about sector coupling in this project. And there are a couple of steps that we will perform in this project to actually reach this objective. But the main idea is really to develop a new service for optimized flexibility in the district energy sector. And the main need owner of this service is the district energy providers. So in focus of the project is that platform that is being developed, built upon Utilifeed and NODA's solutions. And that's combining supply and demand side flexibility. If you have any further questions about this project, please don't hesitate to contact me or reach out via our website, flexisync.edu.
Hello and welcome to this pitch for the cross-central energy control through interconnected microgrids by multiport converter, or as we call it, multiport grid. My name is Jimmy Enberg, and I'm the project manager of this project. This project is a joint project together with ABB, Vattenfall, Aselio, and Akademiska Hus, but also we have some international partners, since it's not only a project within SamspEL, it's also in an AeroNet project. So, and those are the University of Padova and the Barcelona Tech and a Spanish company called Tecnothea. So what is this about? It's about the grid that contain this kind of multiple converter. And what you're talking about is a converter with more than 2 ports, which is the normal case, where you have 1 in, 1 out, or you can both. We got 4 of them, but they can also be AC or they can be DC, connecting grids, loads, batteries, or other types of storage, or even cars or fast chargers. So this is what we're talking about, not only the device, but also the things around it. So this project will be done by starting in the real life, looking into a microgrid and try to build models and their characteristics. Also try to map how this should interact with other parts of the energy system. And through this, analyze the overall performance. What is needed for integrated microgrids or nested microgrids to have a very good overall performance. And based on that, we'll try to identify the most cost-optimal solution for this and how to do it, and then develop control system for that. And then when we're done with that, we would like to evaluate and design a lab scale model, and then take that into the demonstration in the field. And finally, we will contribute and participate in the ERA-NET Energy System Knowledge Community to dissipate research and our results. And if you have any questions, you're most welcome to contact me. Thank you.
Malmö har en kraftig befolkningstillväxt som tillsammans med en ökad elektrifiering av samhället leder till ett stort elbehov. Energibehovet måste alltså mötas med de resurser som finns, men användas effektivare. Malmö stad tillsammans med E.ON, Parkering Malmö, Serneke, Vasakronan samt forskningsaktörerna RISE och Lunds universitet deltar i projektet CLU. Målet är att minska effekttoppar genom bättre samverkan och ökad förståelse. 14 samarbetspartners i Skottland, Tyskland och Österrike deltar i den internationella delen. CLU finansieras med stöd av Energimyndigheten samt erhållit stöd av EU-kommissionens innovationsprogram. Projektet genomför 4 demonstrationer. Syftet är att testa olika fall av flexibilitetsresurser för att öka förståelsen för vad som kan ses som en flexibilitetsresurs, vad deras potential är och hur kan de nyttjas på bästa sätt. Demonstration 1, Smart Charging av elfordon, görs i samarbete mellan E.ON och Parkering Malmö. Här undersöker vi flexibilitetspotential i 2 parkeringshus. Demonstration 2, som undersöker flexibilitet i en befintlig byggnad, genomförs i ett köpcenter av E.ON och fastighetsägaren Vasakronan. Här vill vi öka förståelsen för vilken potential för elflexibilitet som kan associeras med olika typer av uppvärmningslösningar. I demonstration 3 testar E.ON flexibilitetspotential genom att använda ett storskaligt batteri i en urban miljö. Målet är att förstå vilka förutsättningar som krävs för att möjliggöra en kommersialisering inom en snar framtid. Demonstration 4 sker i samarbete med byggaktören Serneke på en av deras befintliga byggarbetsplatser. Malmö, som många andra städer i Sverige, står inför en storskalig stadsutbyggnad inom de närmaste åren, en process som är energikrävande. Syftet med den 4:e demonstrationen är att skapa en bättre förståelse för vilken påverkan stadsutbyggnaden och enskilda byggplatser har på effektsituationen, men även vilken flexibilitetspotential en byggplats kan bidra med. Lunds universitets roll är att identifiera olika slutanvändares flexibilitetsresurser och intressen av att delta i flexibla energisystem. RISE ansvarar för uppskalning av projekteffekter. Vill ni veta mer om CLU? Besök gärna vår webbsida. Tack!
Hello, welcome to this short introduction to the A&M for All project. My name is Emil Hillberg and I'm the coordinator of this project, where we at RISE, the Research Institute of Sweden, work together with partners from Sweden, Germany and Hungary. Among the project participants, E.ON, being the distribution network owner in all 3 countries, is a main need owner of this project. Here we collaborate between academia and industry together with the local community in the development of innovative solutions. The A&M for All project started almost 1 year ago and will continue for 2 more years, and the budget is approximately 3 million euros, which is supported through the ERA-NET program. The goal of the A&M for All project is to develop and demonstrate alternative solutions to traditional network expansions. This kind of solutions are needed to ensure a sustainable development of the power grids and to meet the agility required from the development in demand and production. The core research, development and innovation work in the A&M for All project include first, the development of active network management methods to exploit the flexible assets and optimize the use of available network capacity to permit increases in renewable electricity generation. Development of business models for A&M solutions to provide decision support for market players regarding investments and operation of the distribution system. And finally, the development and integration of a digital toolbox to support the DSO's planning and operational procedures. The work of the A&M for All project will be demonstrated on Öland as well as in Gyöngy in Hungary. During the startup phase of the A&M for All project, we have produced a set of reports which produces the framework of this project, identifies toolbox interfaces, and illustrates how the costs and benefits of A&M solutions can be analyzed. Public reports and other information about this project can be found on our homepage, anm4l.eu. Thank you for listening in.